Alright class, welcome to Math 2015. For today, we have the Learning Outcome 6 handout to go through and learn about these patterns and writing algebraic expressions from the patterns. How you can build that up from these several examples and extend it to further examples. So these are the example solutions. So what we're doing is we're going to investigate these box patterns. And we have a whale pattern to do after that. And then after that we'll do a triangle pattern, matchsticks. Okay, so we'll do the same questions for each one. First of all, when we look at patterns, we want you and you want your students to notice any specific patterns to notice in the pictures. So from the three figures, we have little boxes in there. Okay, so here's little boxes. So this pattern, a growing box is what I would say. Box or square, let's just use square. Okay, so you have this growing square, and then it also has the same four corner pieces. I'll call them corner pieces because they're on the corners of the squares, the vertices of the square. So you have a growing square and you have four corner squares. Now we're going to describe what is changing and what is staying the same. And in this case, it looks like that those things are related to what the patterns we noticed. Changing. We can see that the square, middle inside square, changes. Increases in perimeter, technically, with every figure. What is staying the same? The four corner squares. They're in every figure. They do not grow at all or shrink. Okay. So now we're going to figure out how many squares are in figure 1. But we need to determine this in a systematic way. We want to focus on what's changing and what's staying the same when we count them. Because eventually we want to generalize to figure 2 and figure 3, the same setup. And then we generalize to figure n after that. So in figure 1, we have four corner squares. Four squares on corners. Plus, we have three, you can count them in a couple of ways. So we'll do 3 top squares in the main square. 3 for top row, if you will. 3 squares in top row. We have 3 squares in the bottom row. Plus 1 on the left side. plus 1 on the right side. Okay, so we're counting them up. We've divided up the squares in this way. So we have our 4 corners. Those are in red here. I'm going to zoom in here. We have 3 in the top row, 3 in the bottom row. So I'm counting them that way. Then we have 1 on the sides, so 1 on each of the sides. Okay. So 4 squares in the corner are red. 3 squares in the top row is yellow. And the bottom row is yellow. And 1 on the left side and 1 on the right side. Okay. So that's how I'm counting these squares in my figure. Okay. And when I sum them, we get a total of, which equals 4 plus 3 plus 3, so 7 and 10, and 7 and 10, 11 and 12. How many squares are in figure 2? Now what we want to do here is we want to do the same process, okay? We're going to count the squares in the same way. So there's 4 corner squares. Zoom in, there's 4 corner squares. And there are 4 yellow for the top row. And then 2 on the side, left side and right side. Okay, so we're going to keep track of that. So you have 4 squares on corners. Pull that down so we can see that there. Plus 4 squares on top row of the main big square. Plus 4 squares on bottom row. Plus 1 on the left side. Not 1 on the left side, 2 on the left side. Plus 2 on the right side. Okay, and so when you sum all those together, you get 4 plus 4 is 12, plus 4 more is 16. Okay, so we have 12 squares on the figure 1, and then 16 squares on the figure 2. Okay. All right, figure 3. So we're doing this is to establish a pattern. So in figure 3, let's count the squares. So there's 4 again on the corners, so those ones will stay the same. The top row and bottom row are yellow, and they have more squares in them. The left and right, which are 5, but the left and right ones have 3. Okay, so we're going to go ahead and count those in that same way as figure 3. 4 squares on corners. Let's go back to our figure and see how it looks there. Sorry for all the zooming in craziness, but we're going to add on 5 squares on top row plus 5 squares on bottom row plus 3 squares on the left side plus 2 on the right side. Okay, so at this point, figures 1, 2, and 3, we're doing a bit more work than you probably would want or initially think, but it will pay dividends for when we get to letter G and F and G, so that we can extend our pattern in an easier way. When I add those squares up for part E, we have 4 plus 5 plus 5. So this 5 and that 5 make 10. Then 14. And 14 and 3 is 17. And 3 is 20. Good. So using that figure, how many squares would be in figure 6? So we have the 4 squares in the corners that don't change. So those will definitely be in the figure 6. There are, for figure 3 and 2 and 1, let's see what the top row is. So we have, for figure 1, there's 3 squares on the top row, 3 squares on the bottom row. For figure 2, we have 4 squares in top row and 4 squares on bottom row. For figure 3, we have 5 squares on top row and 5 squares on the bottom row. So as the figure number increases, so does the squares. But the squares and the figure number don't relate exactly. They're close. But how much are they different? Well, it looks like that whenever there's 1, there's 3, and 2, there's 4, and 3, there's 5. So you have to add 2. So when you take my 6, I'm going to add 2 to it, and I have 8. 8 squares in the top row, plus 8 squares in the bottom row. And now on the left and right sides, I need to see what it would be for figure 6. So for figure 1, I have 1 on the left side, 1 on the right side. Figure 2, I have 2 on the left side, 2 on the right side. Figure 3, I have 3 on the left side and 3 on the right side. So it appears that the number of squares on the left or right sides does follow the figure number. So our figure is 6, so we'll do 6 squares, and 6 on the left side, plus 6 on the right side. Okay, and that equals, for a total of 4 plus 8 plus 8, so 4 plus 8 is 12, 12 plus 8 is 20, 26, and then 6 makes 36. Okay, so 36 squares. Now we want to see how many squares are in figure n, where n is any number. And we're going to generalize it. The things that change will be with a variable, because variables change, they express change. Things that stay the same will be constant, so you can keep those as constant. And we're constantly asking ourselves what's changing, what's staying the same throughout this handout right here. What's changing and what's staying the same. So with our pattern, if we continue that with that we're doing with our numbers, we'll have the 4 in the beginning. So there's always going to be 4 there for the squares on the corners. There's going to be 8 squares in the top row, 8 in the bottom if it was figure 6. Figure 3 was 5 squares. So that looks like, and 2 was 4 squares on top and bottom, and 1 was 3 squares on top and bottom. So that looks like a part that changes. Okay, so changes depending on the figure number. So figure number is n, right here. And it looks like that the squares in the top row and bottom row are n plus 2. For the top row. And n plus 2 squares on the bottom row. Now on the sides, left and right sides, it looks like that the figure number and the number of squares there correspond. So like in example number 1, there is 1 square on the left side and 1 on the right, and so on. 2, there's 2 on the left, 2 on the right. So we're going to add on n squares for the top. Oh, sorry, on the left. So n on the left. And which means we do plus. N on the right. Now that's going to equal, when I add the numbers and the variables together. So that's going to equal 4 plus n plus 2 plus n plus 2 plus n plus n. When I add all of those together, I get 4 for my numbers. 2 and 2 make 4, another 4, and then make 8 together. Equals 8. Well, let's do our n's first. So 1, 2, 3, 4. So 4n plus 8. Okay, so if you want to use substitute in the figure number for n, and then you multiply by 4 and add 8. Okay, so it's important to kind of know where the 4n comes from. Where are the 4 squares that I'm adding each time? Okay. And where are the 8 original squares? We can ask those questions. Where are the 4 n squares added, and where are the 8 added? Or are the 8 each time? Because the 4 n squares are going to be the things that change, where are the 8 that stay the same? So in each of my figures, we have, these are 4 squares that stay the same. Right here. These squares stay the same. Okay, circling that in purple. Okay, so where are the other 4 that stay the same? Well, it looks like that these corners inside the square also are there all the time. They stay the same. So circle those in purple too. Across our figures. So we're connecting the math back to the picture. So you connected the picture to the math, now the math back to the picture. Okay, and then we have 4n. So every time that a new figure is constructed, 4 new squares are being added. Okay, And so that will be, let's see if we can circle them in orange. So from the first one to the second one, they added these squares here. 2, 3, 4, let's say. Because the other ones were not there before. And then in this new one, we have these 4 on. 1, 2, 3, and 4. Okay? Because those older ones were there. Just like this one right here was an old one that used to be right here. This one right here was the old one that used to be right here. This one right here was the old one that used to be up here. This one right here was the old one that used to be down here. Okay. So those are where the 4 are coming from. And that is the first part, first pattern here. Now we're moving on to number 2, which is investigating a well pattern in a similar way. First, we want to describe any patterns that we notice. The well pattern looks like it has kind of 2 main components. We have the front part and the back part, with one in the middle. And that pattern looks like kind of a square and a rectangle. So square and rectangle. Oh, that looks like a square there too. But this is a square and that's a rectangle. Okay. So we have a front and back and middle. So front, square. We have a middle, let's say big square. So we got to kind of distinguish. We'll zoom in here a little bit. We have a front big square. Middle square. And the back cube, back rectangle. Okay, those are all little parts of our well pattern. Describe what is changing and what is staying the same. Okay, so from our front big square, that seems to be changing. Middle square. That doesn't change. So we gotta take a look at the middle square for all of them, and we see that it actually doesn't change, it stays the same. So I'm gonna put that in my next category here. So I'll note that down real quick before I forget. Middle little square. And then the back rectangle also changes. The little tail fin thing. All right, let's go ahead and find out how many squares are in figure 1, where we're focusing on what is, continue to focus on what is changing, what is staying the same. Okay. So in figure 1, there are 4 little squares in the front square, front big square. Oops. And I'm going to add on the middle square, so there's one middle square, middle little square. And then I'm going to add on the back, 2 from the back rectangle. And when I add all of those up, I have 4 plus 1 is 5 plus 2 makes 7 squares. Okay, so figure 1 has 7 squares. Now you could probably just count those all out, but it's important to be systematic because we do have a trajectory where we're going to generalize it to a figure that we don't know or don't want to count and draw out, and to any figure with n being the figure number. Okay, so we have 7 squares for that one. In part D, it says how many squares are in figure 2. We're going to continue our pattern. Okay, so we have 9 in our front square. Plus 1 middle little square. Plus 4 in back rectangle. For this one, it's going to be back square. And when you add all those up, you have 9 plus 1 is 10, 10 plus 4 is 14 squares. Okay, part E, how many squares are in figure 3? We have a 16 in front square. We have 1 middle little square still. We have 6 in the back square. Back rectangle. Can we add those up? 16 plus 1 is 7, plus 6 is 23 squares. Okay. So we're establishing our pattern so we can answer questions like figure 20. How many squares are going to be in figure 20? Well, we have our 3 parts, and let's go back to our pattern. Our first 3 figures to find a pattern. Figure 1 had 4 in the big front square. Figure 2 had 9 in the big front square, and figure 3 had 16. Now 4, 9, and 16 we know are perfect squares. But it's not like you square the figure number, because 1 squared is 1, and 2 squared is 4, and 3 squared is 9, and 4 squared is 16. So they do follow a pattern, but they're off just a little bit on figure number. So if we want figure 1 to end up with 4, let's take our figure number and from 1 to 4 you just add 1 and square it, because 1 plus 2 plus 1 is 2, square is 4. Let's check that with figure 2. If we have 2 here and we want 9 there, if we add 1 to it, figure 2 plus 1, you get 3, and you square it, then you get 9. 3 plus 1 is 4, 4 squared is 16. So we just have to take our 20, add 1 to it, and then square it. Okay, so we're going to add that to 1 middle square. We're going to put some labels on here to be consistent. So is that many in the front square? Plus 1 middle little square. Plus the back square is 2, 4, 6. Okay, so we take our 1, figure 1, and multiply it to get to 2. 1 times 2 is 2. That makes sense to check out because 2 times 2 is 4, and 3 times 2 is 6. So you take your back square rectangle and to get to that one, you multiply the figure number by 2 to get that one. Okay, so to recap on that one, the back rectangle is I'm going to take my figure number and add 2 to it, or multiply it by 2. So we take 20 times 2 in the back rectangle. Okay, and what you have is 20 plus 1 squared is 21 squared, plus 1 plus 40, which is equal to, let's see what 21 squared is. We get 441 squares. Okay, so that's how we get that one for the 20th figure. Now we want to see how many squares would be in figure n, where n is any number. Okay, so we're going back to number f, because that's what we kind of use to derive a very large number of squares in that figure. So we're adding 1. For the front square, we're adding 1 to our figure number and then squaring it. So that would mean that we add 1 to n and then square it in front square. Adding the 1 middle little square is still the same. And that one will be same throughout. And the other one is the back rectangle. That changes, so we're going to put our n in there, and it looks like you just multiply by 2, which is 2n, and to get your total. Now the total will be n plus 1 squared plus 1 plus 2n. Okay, so that's the same as n squared plus 2n plus 2 plus 2n, plus 1 plus 2n, which is equal to n squared plus 4n plus 3. So that's interesting here. N squared plus 4n plus 3. Okay, so just like on the first one, we're going to do where are the different parts, where are the different parts of the formula here in this square. So our formula is n squared plus 4n plus 3. Okay, so where are these parts? Okay, we want n squared. So the only square on this, and we'll go to figure 3, is right here. So this will be my n squared here. Just find somewhere where there's 3 the 3 squared from 3 by 3. Now 4n, now that means that every time I get a new figure, 4 squares are going to pop up somewhere. And we also have 3 that are going to be there all the time. Okay, and it looks like, well, the 3 that could be there all the time, okay, I think I got it here. Let's see, the 3 there all the time, zoom in here. So we're doing 4n plus 3. So we need 4 n's. We need 4 separate groups of 3. So let's just take these 3 right here. So there's always going to be those there. And there's always going to be those here. Okay. And that's 2 groups there. Here's going to be my 3rd group on the back, and 4th group on the back. There's 4n. Well, where's the 3 coming from? 4 times 3. Yeah. Yeah, because we know that that middle this one right here. That one right there. We have one right here, but there's only 2 of them. Okay, yeah, I miscalculated right here, so boom, that's supposed to be 1. Because 1 times 1 is 1. From this part right here. Alright, great. So that's actually n squared plus 4n plus 2. Okay, and the 2 are the green squares. So the n squared is the red in the figure. The 4n is the yellow in the figure. And the 2 is the green, because there's 2 there, 1 on the corner and 1 in the middle. Okay, so identifying those parts is a part of the fun of doing these here. Okay, so my n squared here is this red part right here. 4n, so we have 1, 2, 3, 4, and then the 2, let's change that to a 2. Just copy that one. Our green, they will go right here and right here. Okay, there's our second page.